Search a 2D matrix. Given an m cross n integer matrix with the following two properties, the first being each row is sorted in non-decreasing order, that is in ascending order with duplicate values. For example, this matrix, it's sorted in ascending order and there are duplicate values over here, right? And the second being the first integer of each row is greater than the last integer of the previous row. That is, in case of each of these rows, the first value of each row is greater than the last value of the previous row, right? 3 is greater than 2, 9 is greater than 6. And how it should not be? The matrix should not be like this. Why? Because here 4 should be greater than 6, right? We shouldn't have 4 over here. This 4 is actually lesser, right? And given an integer target, return true if the target is in matrix or false otherwise. So for this matrix, if target is 6, then I'll return true. Why? Because 6 is present in the matrix. And if the target is 11, then I'll return false because 11 is not there. And most importantly, solution must be in less than log of m into n time complexity, right? How do we do this? Well, it's pretty simple. First, consider this particular matrix. Here our target is 127. If we directly try doing linear search, how it's going to go? Well, we'll start from the top left corner and we'll just proceed cell by cell till we find our target, right? So in this case, our target is 127. So here we reach 127. So the problem with this solution is the worst case time complexity is m into n, which we don't want. We want lesser than log of m into n, right? So let's see how we approach this problem. If you recall, in binary search, if we are given an array, what do we do first? We find the mid, right? And with this mid, we compare our target. If the target is lesser than our mid, then we proceed to search on the left part, right? On the lesser side of the array. And if the mid is lesser, that is our target is greater, then we'll search the greater half of the array, right? So why this is important? Because can we think of our problem in a similar manner? Can we find a mid in our problem? Let's see. The same previous matrix with the target of 127. How can we find a mid? Now we have bunch of options here. The first being the top left corner. Here, can we call this as a mid? No. Why? Because the problem here is all the elements on the right side of this is greater. That is fine. But all the elements to its bottom is greater than. It's again greater than 1, right? Even to the right it is greater, even to the bottom it's greater. So we can't use this position. And similarly, this 278, we can't use this as well. Why? Because we have a similar problem. All the elements on the top are lesser than 278 and all the elements on the left are lesser again from 278, lesser than 278. So what remains are this position 10 and 188. Now these are perfect positions. Why? Because here on the top we have all the elements lesser and on the right we have all the elements greater. This is a perfect, very convenient position for our mid because we can search now very conveniently. But let's start from our 10. Okay, here also we can approach in a similar manner. On the left side everything is lesser and on the bottom everything is greater, right? So 10 is lesser than 127. So we go to the greater part of the array, right? So we'll go to 24. 24 again is lesser. So we'll go to the bottom where our greater part of the array resides, right? So 63, again lesser, again we'll go to the bottom, 100, again lesser, we'll go to higher element, 180. Now 180 is greater than 127. So now we finally have reached a place where we can find the lesser part of the array, right? So here we have to move left side. So we'll go to 171. Again, 171 is greater than 127, so we'll go to left. 156 greater, we'll go to left. 134 greater, and then finally we have reached to our target element. Pretty simple, right? Let's do it with the bottom left corner. Okay, our target here, let's have 61. With 188, it's on the right side, the greater elements, and on the top we have lesser elements, right? So now 61 is lesser than 188. So where do we go? We go on top, right? So we go to 110. I mean 110, right? Again, it's greater. So we go to 65. 65 again, it's greater than 61. So we go again on top. 25. Now finally we have reached a position which is lesser than 61. So now where do we go? We go to the right. We go to 25. 25 is lesser again. So we go to right. 50. 50 lesser. 52. 52 is again lesser. Then we'll go to right. 56 again it's lesser, and then finally we have reached our target 61. We can do it either way. Either from top right or from bottom left corner. Now the worst case time complexity will be m plus n. As no matter what number you choose to search, it will always search in worst case an entire row plus an entire column. Okay, not more than that. So this was all about the concept, how we approach the problem. Now let's code it out. Okay, let's start with the solution. The first thing I need to clarify is that I am going to traverse our matrix from top right. Okay, so that is our row will be equal to 0 and our column variable will be equal to length of the matrix 0. So the length of the first row, and which is the length of the the number of columns, right? And minus 1. Okay, because since we are starting from 0 to length of the matrix, right? Anyway, so now I have decided that I'm going to traverse from top right. So I also need the bounds, right? So the first bound will be our total rows. It will be length of the matrix. Okay, so now the second bound will be if we have lesser elements, I will go to the left, right? So the left will be at max we can go till 0, and after that we have minus 1 that we have reached out of bounds, right? And similarly in the bottom we are going to go max at the total rows, that is length of the matrix. After that we have out of the bounds, right? So here I am going to initialize our while loop. While row is less than our total rows and column is greater than minus 1, I need to first check whether I have reached the target, right? So whether row and column is equal to target. If it is, then I'm going to return what I'm going to return. I'm going to return true because I found the element, right? And if not, okay, if matrix row column is less than target, sorry, target. Then of course, now since our matrix is element is less than our target, that means I need to go where? To the bottom, right? Because I want to find my target in the higher part of the matrix, right? So I'm going to go on the bottom, that is increment my row. Else, finally, this is the condition, like if the matrix row and column, our cell value is greater than the target, right? So definitely our target is less, right? So we need to go to the left. So column will be decremented. And this is it with the while loop. And the final thing, like if we don't find any value in, like we don't find the target value, then what do? We return false, right? Let's run the code. So code is accepted. Yeah, the code is accepted. Now let's submit it. Yeah, beats 100%. Pretty good solution. That's all guys for this video. If you liked it, please click on that thumbs up and subscribe. And I will post regularly. I'll try to post regularly now. And I am also open for suggestions, like whatever problems that you have, LeetCode problems that you have, you can suggest in the comments. Okay, thank you.